Okay, getting ready for our circular functions unit assessment. It occurred to me when I was writing this thing that y'all have never actually seen the word written before, so I wanted to make sure you did before the unit assessment came along. The word here is arcsine. It's one that you haven't gotten real accustomed to. I say it in class, I don't think I've actually ever written it out this way. So I wanted you to see it before we got it done, and then give you a little bit of intuition behind why it works. If you're looking for the sine of theta, some measured angle, theta, and you know that sine of theta is -1/2. The way that you can go about finding the measure, because what you want here is you want to know what measure of the angle will give you -1/2. What measure in degrees or in radians? And the way that you can, I guess, kind of take away the function of sine is by multiplying or taking the, y'all might think of this as the inverse of sine. It's actually referred to as the arcsine, A-R-C-S-I-N. And there's also an arc cosine, there's an arc tangent, and those are written this exact same way. Cosine, you might think of it as to the -1 power. I'm going to tell you, please don't. Or tangent, or the inverse of tangent. Those are arc cosine and arc tangent. But this time we're working with arcsine, so let's get back to our original. The purpose in doing this is so that this function, arcsine, basically does away with that function because it's the inverse of something. It undoes it, and it leaves us with theta. Please don't think of this as canceling. It simply undoes that function. But whatever you do to one side of the equation, you have to do to the other. So we did this. We used this function on that side of the equation, so we need to use it on the other side of the equation. Sine, or arcsine, of -1/2. And that's what theta is. It's the arcsine of -1/2. So if you reach for your graphing calculator, you'll notice on the TI-84, and you have this on your laptops as well. Remember, guys, they've uploaded the TI-84 emulator on there called Wabbit. If you will look at the writing just above the sine button, you'll see sine and -1. That's the inverse of sine. So you can put yourself in either degrees or radians. I think most of you will probably start out in radians. Start out in degrees. I think that's appropriate. So if you hit second and then sine, it says sine -1 in this parentheses, and it's waiting for some input. So -1/2 or -0.5, close the parentheses and hit enter, and it tells you that the measure that it generates, what value of theta would give, when you put sine to the measure of -30, you get -1/2. And that's what all this is telling us, is -30 degrees. Now, if I want to convert that into radians, probably the easiest thing to do would be to build yourself, you know, a kind of a quasi or just a real quick thumbnail sketch of a unit circle. If this is 0 degrees, so we have this unit circle, and we want to draw out about 30 degrees. Well, that would be in a positive direction, 30 degrees, but the answer that we've got thus far is -30 degrees. So let's move in the opposite direction. We're going to move down here. You know, that's not wholly, that doesn't look quite right. Let's try and make this a little bit more believable. Let's go out here about, it's close. All right, so -30 degrees, and we're trying to get the idea, you know, what is the arcsine of -1/2 of degrees in radians? If I want to turn this into radians, I could see that going from 0 backwards would be -180 degrees or -pi. Well, this mark right here is halfway, so -pi halves. And if I keep the same thought, where I've just drawn this line, I can break pi halves up into 3 equal chunks, and that would make each one of these a pi sixth. So 1 pi sixth, 2 pi sixths, actually that's negative for each, and negative, I just wrote negative 2 pi thirds, there we go, 2 pi sixths, sorry, and negative 3 pi sixths. Each one of these is 1, 2, and 3 pi sixths, and sure enough, that would simplify down to that. So this all gets around to simply saying that this angle that I have just drawn, negative 30, is negative pi sixths radians. So let's write that in, negative pi sixths radians, and I've answered my question.